Let's tackle a second example now. Now, the first thing I'm going to do every time is remember my little acronym of my curve sketching menu. So, please do support ISA. That's the one I've chosen to remember. You might have your own. So, as I do each one of these, I might just circle it so I know I've taken care of it. P is for prepare. Now, I need to prepare my function. Can I factorize it, or can I tidy up the fractions and give them a common denominator? Yes, I can do that. Now, to make common denominators, I just want to multiply my denominators together. So if I'm going to make one big denominator, x minus 2, x minus 8, then on the top I'm going to have two terms, one from here and one from here. Now, this part of the fraction I've multiplied by x minus 8, so I need to do the same to the top. So this becomes x minus 8. But over here, I've multiplied this part of the fraction by x minus 2, so I need to multiply the top by x minus 2. So I have plus x minus 2. Now, notice how I put brackets there. That's just a habit, really. I don't really need the brackets because this is a plus. Neither of these signs is going to change, but always beware, if you had a minus sign here, you'd have minus in brackets x minus 2. That would be an opportunity to make the classic sign error. Don't fall for it. So think about whether you need the brackets, and as you go to write them, you can almost sort of see, all right, well, I don't really need those this time. But if there was a minus, I would. All right, tidying out now. I might just keep working across to give myself some more space. Y is equal to x plus x is 2x, and minus 8 minus 2 is minus 10, over x minus 2, x minus 8. And I could even factorise the top if I wanted to. I'll work down here and say that's 2, that's over x minus 5, over x minus 2 multiplied by x minus 8. Okay, so I have now prepared my function. Next thing to do is to find the domain. So the domain says what values of x might be possible or impossible. Well, I could sub any values of x into here and do these functions with them, but the only real limitation is that this part can't equal 0. So I'm going to go ahead and write that x minus 2 times x minus 8 can't equal 0. Therefore, x can't be 2 or 8, because if it was 2 or 8, it would make both of these 0 and I'd get 0, which I can't have. So, x can't be 2 or 8. Now, let's start with our graphing over here on the side. X can't be 2, or if that's 2, let's say 4, 6, 8 can be here. Can't be 8. Alright, I've got started. One thing I'm thinking already is this probably isn't an even function, is it? It's got two asymptotes on the same side, so already I can see that there's no symmetry left to right there. Alright, I found my domain. Next thing to do is to investigate the symmetry. Now I can tell straight away it's not an even function, because if it was, I would have asymptotes over here at minus 2 and minus 8. I can also see that it's not an odd function, because an odd function involves a rotation of 180 degrees around the origin, and that would also give me some asymptotes over here. So if I wanted to check for oddness of the function, I would do this test, but this is going to be time consuming, subbing all of that into here, and I can already see that it's not necessary. I've thought about it though, so I'll tick that one off. So I can see that my function is neither even nor odd. Next thing is intercepts. So let's look for x-intercepts by letting y equal 0. Well, if I let y equal 0, then all of this part that's on the right-hand side will only equal 0 if the numerator equals 0. We know the denominator can't. So we must have 0 divided by something to get a 0 over here. So that means that 2 multiplied by x minus 5 would have to equal 0. X minus 5 would have to equal 0. Obviously 2 can't, it's 2. So x would have to equal 5. So that gives me an intercept that I can put straight away over my graph. I've got 2 and 8 here, it's exactly in between them, so there's some symmetry there at the point x equals 5. And I know the graph goes through there. What about when I let x equal 0? What would y be? Well, let's just sub it in. Y is going to be 2 lots of negative 5, that's minus 10, over minus 2 times minus 8, that's 16. So minus 10 sixteenths, that's the same as minus 5 eighths. So I can put that here, it's going to be around about here somewhere, minus 5 eighths. That's my y-intercept, and there's only one of them. Alright, intercepts are done. Next thing to consider is the sign of the function. So I've got some places I want to investigate. I want to see what it is on this side of the asymptote, and on either side of this x-intercept, and on either side of this asymptote here. So I'll just rub this out to give myself a bit more board space. Alright, working up here, if I do myself a quick table of values, I want to investigate what's on this side of the 2. So let's let x equal, say, 0. We can pick 2 itself. We've got 3. We want 5. We want something in between 5 and 8. So let's go 6. We want 8. And we want something bigger than 8. Let's go 10. And filling in this table, I can see that the easy ones to do were when x is 2 and 8. I know that I've got asymptotes there. I'll just put an asterisk. When x is 5, I know I've got a 0. So I only really need to calculate 4 values there and see whether they're negative or positive. So I've done that. This tells me that over this side of the asymptote, the graph is below the x-axis. The sign is negative. In here, it's positive on this side of the 0, but then negative on this side. So we're going from up here, oscillates towards this, to coming down here. And then on this side, we're positive. So I've thought about sign. Now to check for asymptotes, we've already got some vertical ones. So really at this point, we're checking for horizontal asymptotes. Now, we found a method to do that. We said divide the original function by the highest power of x that's in the denominator. But the reason that we're trying to do that is we're trying to get our values of x being on the bottoms of fractions, like this. Okay, that's why we divide by x, and we get x's down the bottom. Because when we do that, we can say, as x approaches infinity, this expression, and it can have anything on the top, doesn't need to be 1, it could have any number divided by x, is going to approach 0. Now have a look at our 2 forms of the function. This is the one that we were given, and this is the one that we prepared because that made it easiest for us to find zeros and asymptotes. Now if you actually look at the original function, it already has all of the x's on the bottoms of fractions. So this is actually prepared perfectly for us. We don't need to divide by the highest power of x. If we do, we'll just end up with a really complicated looking thing that's going to be hard to manage. So I can actually ask myself this already. As x approaches infinity, or negative infinity, what is y going to approach? Alright, well, as x gets really, really large, this is going to be virtually infinity here. And 1 over a massive number is basically 0. Similarly, this is going to be basically 0. So I can see that as x approaches infinity, y is going to approach 0. That means that as we go up this way on the graph, y is going to come down and closer and closer and closer to 0. So that gives me an asymptote out here as x gets really, really large. What about if x was negative infinity? Same thing, we'd have 0 plus 0. So that tells me that out this way, we're going to approach 0 as well. Now this function is quite tricky. We can't draw our asymptote all the way through. And the reason we can't is we've already seen from the sign of the function that in here it's positive and in here it's negative, and we have these asymptotes. So this section is quite easy to rough in like this. It's something of the shape of sort of a negative cubic section of a curve. But out here we have asymptotes, and we know that over here the function is negative. So we have an asymptote and another asymptote. That means it's likely to have a shape that's something like, oh, no, it won't be like that because we already have this intercept. We've got to make it go through there. It's going to have this basic shape. And out here, where it's positive, it's got an asymptote on the 0 and out here, so it's going to have this basic shape. And it gets this part of its shape from the fact that the curve y equals 1 over x looks like that. And obviously we don't have 1 over x. What we've got is something a little bit more complicated. And the complicated part is what we're seeing here in the middle.